Okay, welcome to my YouTube channel. Welcome to Physics 5054 Explained. Okay, I'm sure you have seen our previous videos where we did our first ever series of answering a past paper question from 2017? Yeah, the whole paper. It was done in episodes. If you're trying to solve the whole paper and you're stuck on a certain question, which is 2017 school certificate, you can go and watch those videos, then you're able to get reference on that same question. So now on this, how am I going to call this one? Series, yeah. In this series, it's another series we're going to do the whole syllabus. No solving, yeah, some solving will be required, of course, in certain topics, but mostly to be explanation. So here is the syllabus for Physics 5054, Ministry of General Education, Northern Province. This is in Zambia, but I'm sure even Cambridge. Physics 54. 5054 is one and the same. The one in Zambia is one and the same. So if you are sitting for GC, is it not GC? If you are sitting for Cambridge, yeah, this is your channel as well. If you are sitting for Pure Sciences is in Zambia, this is your channel as well. For you can watch. The content is almost the same, but I'll be specifying whether I'm dealing with Cambridge or ECZ standard. As for this first video, we're going to do ECZ, which is grade 10 physics, week beginning there, which is week 1. We're going to look at general physics. Mainly we're going to talk about international system of units, distinguish between basic. Let me just get my pointer. Yeah, as I was saying, we'll continue knowledge. You need to know at the end of this video, you need to know the difference between basic and derived quantities, basic quantities, mass, length, time, and etc. You need to know as well derived quantities, force, acceleration, and velocity, etc. And the methods, there are many methods: question and answer, demonstration, even practical work. References, you can use references. References, the books you can use Essentials of Physics. Let me just try to get my pointer. Yeah, I think here the pointer is not, but I'm sure I can be able to see Essentials of Physics where it is written in reference. Those are the books we're going to be using in this series. Okay, so without any further ado, let's look at general physics. First video to be on what? General physics. Okay. Let's go to our books. Which book are we going to use? Let's see. Summarize notes. Not so good. This one, Oxford. No, not good as well. Since we are looking at general physics, we can use topical. Yeah, I would advise you use topical. Topical is really good. It has simple and straightforward notes. Yeah, so that any further ado, let's start our main purpose of this video. You can download it at school.com, or you can contact me. I can very send for you this book for physics. This in the same topic in our syllabus for ECZ is also the same for Cambridge. The first topic is what? Physical quantities and units of measurements is one and the same thing. So you can actually use this book. Candidates should be able to show understanding that all physics quantities consist of the numerical magnitude and the unit. B, recall the following basic quantities and their units. Mass, you need to know mass and their its units. You need to know length and its units. You need to know time and its units. You need current. You don't know current, what is current and its units, and so on and so forth. See, all these things we need to cover up in this video, so I'll be a bit fast, but I'll try to explain as well. Okay, notes 1.1, physical quantities and SI units. Physical quantities consist of what? Numerical magnitude and denotes the size of a physical quantity. Units denotes a physical quantity it is expressing. Units are just there to tell you what. Numerical magnitude denotes the size of a physical quantity. In short, the numbers which are going to be used in these physics videos or this physics lecture or lessons, they are going to be used just to denote the size of that figure, that substance we are looking at. Then the units, it denotes a physical quantity it's expressing. Units are there to help us to know whether we are dealing with what. Are we doing with mass? This number, is it talking about mass? Is it talking about weight? Is it talking about force? Is it talking about acceleration? And all that. So units are very important. That's why when you're answering questions in the exam, units are very important, because you can find the correct answer, but with no units, that answer will be wrong. Why? Because we don't know what you found. We don't know if you're dealing with bananas or orange or what you need to specify. That's why units, they denote the physical quantity it is expressing. That's the meaning of that. Then we go to 2. Basic physical quantities can be classified into. We have A, basic quantities. Okay, basic quantities, these are simply the beginning of measurements, the beginning of all measurements. These are what you call basic quantities. So examples of these basic, let me just get my pointer. Okay, so examples of basic quantities, we have length. Length is SI unit is what? Meter. It's in name of the SI unit is what? Meter. Its SI unit is m. Then you have mass. Mass is name of SI unit is kilograms. Then its unit is kg. You have the name here in full, then you have the symbols or in short. Just don't get confused at why I'm saying units here, again put units there. This is just the full name. If you want to write the full name of the SI unit for length is what? Meter. This is how you write it. Then if you want the symbol for meter, it's m. So applies to all these other quantities. Basic quantities. Time is measured in seconds. Its unit is s. Thermodynamic temperature. Its unit is Kelvin. It's measured in K. Just like that. Then we'll go on to sorry about that. And we'll go to I've explained the basic quantities. Now we go to derived quantities. Okay, derived quantities define in terms of basic quantities through equations. Okay, derived quantities, these are just quantities which are gotten from what? Basic quantities. You understand? It's like you fuse time and let's say you fuse mass and length, that the equation or the units you get is you get what? Derived quantities. Why? Because you have involved 2 basic quantities, and what is what you call what? Derived quantities. SI units for these quantities are obtained from the basic SI units through equations. Okay, example 1. You have density. Like I said, you have combined 2 basic quantities. You have mass there. Another example of basic quantity is what? Volume. So now to make a formula or units for density, what do? You just simply divide. When you divide, let me just get my pointer here to show you something key. Okay, here we go. Say here we want to density is an example of what? Derived quantities. So now, if the formula for density is what? Mass over volume. If you want to write the units or want to find out the units for density, how are we going to write the units? We know the fact that the units for mass is what? Kg. And we know the fact that the units for volume is what? Meters per meters cubed. So to convert this dividing sign or this line here on the middle, this changes to what? To a slash. Hope you have seen there between kg and meters cubed. It changes by what? Per slash. So this simply means that kg, you divide kg by what? The volume. That's where this slash is coming from, and that's how the units for density are gotten from. If you want to define density, you can use even this same formula to define what density. You can simply say, okay, density is what? Kilograms per. I even explained in my previous video there what per stands for. What per stands for? Per simply stands for divide. So if you say kg per, it simply means we're dividing something which comes next after per, which is what? Volume. So here you simply say density is kilograms per volume of a substance. That's how you define what? Density. That's one of the beauty of physics. You can use just for formula to define. If I actually define a certain term, just use the units. If you understand how the units are working, you can use that to your advantage to define what a term and even get a mark in the final exam. Okay. I got to 3. Units of measurements. SI units are used as standard units in all measurements in the world. SI unit is a short form for International System of Units. SI unit stands for what? International System of Units. Then go to 3B. Other units, you have 1 kilometers simply means key or pointer, just like that. Okay, 1 kilometer simply means 1,000 meters. 1 meter simply means 100 centimeters, and 1 centimeter simply means what? 1 millimeters. In the exam, they can give you this and ask you to convert it into what? Kilometers or into centimeters. Then they can also do the opposite. They can give you this figure. They're not going to give you straightforward. Nope. Don't get confused or don't get relaxed. This is pure physics we're talking about. We're not going to give you in a direct format and no, convert this, no. They give you in a question. In the question, it will just be just a step for you. That's the best way I can say it. It will be just a step for you to conversion. Just need to say like, how can I say it? For you to complete grade 12 or to sit for an examination, SBA is just what? A step. Or sitting for an exam, just a step. Studying for it, just a step. So you can be studying, but if you don't go and sit for that exam, you won't pass that exam. So going to sit in that examination or is what? A step. So this is changing in physics, changing units converting units is just a step you need to know, which is very important as well. Hope here is clear. Okay. You go to examples of some derived quantities and their units. Okay, so examples of derived quantities: you have area there, you have volume, you have density, you have speed. A complete list of key quantities, symbols, and units used for all level of examination can be found in the syllabus. True. If you have a syllabus, you go at the far end, you find all the units. Now let's talk about prefixes, symbols, and orders of magnitude. Prefixes are those numbers we should add at the beginning of the word. Example, you need to understand when they say kilo, what do they mean, which means it's 1000. When they say this, what do they mean? It's 1.1. When they say millimeters, what do they mean? All those things are just steps you need in physics. Example there, you have that to convert into standard form. When millimeters are too large, too tight, all those things you need to know. You know them. Orders of magnitudes are often being used to estimate numbers which are extremely large to nearest power of 10. Others examples. The following table shows how orders of magnitude are used to compare some masses and lengths. Electrons, it has that figure, all those things, or this find the ratio of what activities. Okay, you go to 1.3. 1.3 here, you need to understand this. To understand this. Because a scalar, what is a scalar? A scalar quantity has only magnitude but does not have direction. A scalar quantity, let me just point my pointer. This comes in the exam, so I'll spend a little time explaining, and those which are not very necessary, I'll be moving. Sorry for that. So key. Okay, so a scalar is a quantity that has only magnitude but does not have direction. Example of this, we have time, distance, speed, and work. It doesn't. Time can be measured in numbers, but it won't tell you that it's going left or right or upwards or downwards or horizontal or vertical. What does that mean? It means substances that cannot give you direction. We call them scalars. While substances that can give you direction and size, we call them vector quantities. They have both magnitude and direction. Example, we have weight. Weight, it has a size, and it can also be downwards, which is positive gravitation, and upwards, negative gravity. Even velocity can be negative velocity and positive velocity of directions, and so on and so forth. So the key point you need to get here is this statement which is here, both magnitude and direction, while this has only magnitude. Then you're home and try. Okay. Example, the velocity of a particle can be stated as the speed of a particle is equal to that 2 meters per second, and it is moving at an angle of 30 degrees above horizontal. Okay, you have that diagram right there. Addition of vectors involves magnitude and direction. Examples of 1.5, find the resultant force R. The resultant force, just simply use the PAG, that one, whereby you say R squared is equal to A squared plus A squared again. The one which is done in grade 9. Up you can see Pythagoras theorem. Pythagoras theorem, that's what I use to find what resultant force. Here you just square the 4 and there the 20, then you here it's stated here. What I'll say. Let me just get my pointer, and here we go. Okay, just use the formula. We have put a square root, but it's one and the same thing. F1 is the one going upwards, and then F2 is one going horizontal. Then you just plug in here, then you'll find your answer. That's your resultant force. Physics is simple. Just need to understand the basics and how to convert units. Then we'll go on. We have a graphical one. It's quite involving, but if you're interested, you can read on this as well. But I won't waste much time because we'll be moving with time. Measurements of length shows key measurements of length. Choice of instrument depends on the degrees of accuracy required. Okay, range of length, you have that. Instrument measuring tape is accuracy is 1.5, which means cannot go beyond, cannot measure anything less than 0.1. Meter rule cannot measure anything than 0.1 centimeters. Then the calipers cannot measure anything less than 0.01 centimeters. And the micrometer screw gauge cannot measure anything less than 0.001. Examples of things can be measured. You can use that to measure a waistline, height of an object. You can use a meter rule. Vernier calipers can use to determine the diameter of the beaker, the thickness of the length of wire. Use a micrometer screw gauge. How a parallax error can occur during measurements. So when you're using a meter rule, if you want to see the measurements on that rule, how do you do it? You shouldn't. Let me just get my pointer. You shouldn't place your eyes in that direction, or else the measurements will be wrong. You shouldn't place your eyes in this direction, or else your measurements will be wrong. The right way to press when you're measuring an object using a meter rule should be like here. The eye is pointing directly there. This question always comes in the exam as well. That's you mean the error possible errors which can occur. These are the what you call what? The parallax error is one of the examples, and this is how it happens. Okay. The object is not touching the mark of the scale. Another way is by doing this. There should be a gap there. The ruler should be slanting. The correct way should be like that. Measuring instruments can give precise but not accurate measurements. What are we looking at? Oh, then your calipers. Okay, this one will be done on the next video. Thanks for watching Physics Explained.